Hi students, welcome to Madras Math Kernel. Today you are going to learn a new chapter, chapter 3. So in this chapter what you are going to learn? You are going to learn about the pair of linear equations in two variables, right? So you are going to learn the concepts and examples, explanations pertaining to your exercise 3.1. Okay, so first you should know what you mean by a linear equation in two variables. I have given an example here. I have taken an example 3x plus 4y equal to 20. So here if you see the number of variables, x and y are the variables here. So you can observe two variables are there in the given equation. And also after substituting, and also if you inspect the degree of the variables, here x is 1 and your degree of y is 1. So in a given equation, if you observe the degree of the variable as 1, then you can call that particular equation as linear equation. Here since this equation is in two variables, you can call the given equation as a linear equation in two variable. Okay, so here I have substituted x equal to 4 and y equal to 2. So after substituting x and y values in the considered equation, I am getting 20 equal to 20. So what I can infer from this 20 equal to 20, 4 comma 2 lies on the line representing the equation. That is, being a linear equation, giving various values for your x and y, you can draw a straight line like this. So actually this line represents the considered equation here. So what is this 4 comma 2? Actually after substituting 4 comma 2 I got 20 equal to 20. So from this what I am inferring, this 4 comma 2 lies on the line what you have drawn on the graph, that is which represents the given equation. Similarly I am substituting x equal to 2 and y equal to 1. After substitution I am getting 10 equal to 20, which means it's a false statement. The considered point 2 comma 1, it is not lying on the line representing the given equation. So it's not a solution. 2 comma 1 is not a solution. That's what you are inferring after substituting a particular point in the given equation. Similarly, if I substitute x equal to 0 and y equal to 5, I am getting 20 equal to 20. So what you can infer, this point 0 comma 5 lies on the line drawn there. Okay. So from this what you can understand, each solution x comma y, that is each points of a linear equation in two variables ax plus by plus c equal to 0, they corresponds to a point on the line representing the equation. Each and every point lying on the line you can consider as a solution for the given equation, right? So now you consider a pair of linear equations. So the general form of pair of linear equation is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. And a1, a2, b1, b2, c1, c2 all belongs to the real numbers. So whenever you are given with two lines, what are the possibilities for those two lines? So if you see the possibilities for a given two lines in a plane, either they can intersect each other like this, or they can be parallel to each other like this, or they can be coincident. This is line 1 up to this and this is line 2. They can be coincident like this. So these are the possibilities for given set of two lines. Okay, when you are given two lines, and then so this is the theory part over there. And coming to example 1, Akila goes to a fair with rupees 20 and wants to have rides on the giant wheel and play hoopla. Represent the situation algebraically and graphically. Algebraically means you have to represent in the form of equations, and graphically means you have to draw it as a graph. Okay, so number of the conditions given is number of times she played hoopla is half the number of rides she had on the giant wheel. If each ride cost rupees 2 and a game of hoopla cost rupees 4. Okay, so this is what your question. So what I am doing, I am assuming let x the rides on the giant wheel and y the number of times hoopla played. So as per the given condition, number of times she played hoopla is half the number of rides she had. So hoopla, how many times she played? I have assumed it as y. So number of times hoopla played is equal to half the number of rides. So half of the number of rides on the giant wheel, I have assumed it as x. So after performing the after taking this 2 to the other side, you will get 2y is equal to x. Therefore x minus 2y equal to 0. This is your first equation. Coming to the second equation, 3 is the amount charged for the giant wheel, and 4 is the amount charged for playing hoopla. Okay, so 3 into x plus 4y equal to 20. This is the second equation because she is having 20 rupees in her hand, and these are the number of rides and number of games played in the giant wheel and hoopla. Okay, so what I am doing, I have drawn a tabulation like this. I have substituted x values in the y equation. So I have taken randomly x as 0 and 2, and y is x by 2 derived from the first equation. Y is equal to x by 2. So because already I have written here y is equal to half of x. So this is what your x and y values here. So first I have taken x as 0. So I arrived with y value as 0, and similarly after substituting x equal to 2, I got y as 1. This is for first equation. And from second equation, so what is my second equation says? So what is my second equation says? 3x plus 4y equal to 20. So first I have in the table I have written x here. Then how to find out y? If you want y, 4y is equal to 20 minus 3x. 3x will go to the right hand side, and again if you want to y, 20 minus 3x divided by 4. Okay, so performing simple calculations or simple techniques there. So y is equal to 20 minus 3x divided by 4. Okay, so here I am substituting x as 0. I got 5. Then the simple method to get the point is, simple procedure to get the points easily is, first you have to substitute x as 0, then you have to observe the y value. In the next step you have to put y as 0, then you have to observe the x value. This technique will hold good in almost all the problems. In some problem it will not be okay. For example, here I have substituted x as 0, I got y. Here after substituting y as 0, I got a fractional number. So whenever you get a fractional number, it's very hard, or it's not easy procedure for you to mark it in the graph. So in order to make this as a whole number, I have randomly selected x. So I have taken x as 4, then I got y value as 2. So almost for all the problems, these two values are okay for plotting the lines. Sometimes if you get a fraction, then you have to go for one more value. So why you are going for one more value? To make your work simple. Okay, so now I have plotted the points. I got one per, this is the points for the equation taken, that is 3x plus 4y equal to 20. This is your second equation, and your first equation is y is equal to x by 2, half of x. Okay, this is your second equation. I have marked all the points over there. For first equation, I got 2 points. One is 0, 0, another one is 2, one is 0, 0, and another one is 2, 1. And for second equation, 0, 5 and 4, 2. 0, 5 and 4, 2. After marking these points, I connected with the help of a scale. I got a straight line over there. Okay. After drawing these lines, I observed these two lines intersect at the point 4, 2. Therefore, what you can say, 4, 2 is the point of intersection of both the lines. Okay, this is the solution for this problem. Okay, coming to example 2. So Romila went to a stationery shop and purchased 2 pencils and 3 erasers for ₹9. Her friend Sonali saw the new variety of pencils and erasers with Romila, and she also bought 4 pencils and 6 erasers of the same kind for ₹18. represent the situation algebraically and graphically. Okay, so as usual, I'm assuming x as the cost of one pencil and y as the cost of one eraser. So Romila, she bought how many pencils? 2 pencils and 3 erasers. So 2x plus 3y equal to for rupees 9. This is my first equation, and similarly 4x plus 6y equal to 18. That is my second equation, because y 4 and 6, 4 pencils and 6 erasers are bought for rupees 18 by her friend Sonali. Okay. And then regular procedure, you put a table like this, you find out your x and y values for drawing the lines. Okay. So for first equation I have taken x, and y I found out from the second equation, 9 minus 2x by 3. After substituting x equal to 0, I got y3. After putting y equal to 0, I got x as 4.5. Similar procedure I adopted for this equation 2 also. So I got the points 0, 3 and 3, 1. Okay. So after plotting the points what we got as straight lines, I got, this is the line for first equation. What is your first equation? 0, 3 and 0, 4.5. So 0, 3, 0, 4.5. Sorry, 0, 3 and 4.5, 0. So these two are the points for first line, and then your second points are points of second line are 0, 3 and 3, 1. So again this also comes for your second line, 0, 3 and 3, 1. So this is the point of my second line. So after joining all these things, I observed both the lines, they coincide with each other. So now this is the answer for your example 2. Okay, so coming to example 3, two rails are represented by the equation x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 equal to 0. Represent this situation geometrically. So geometrically now you have to represent in the form of a graph. Okay, so again following a similar procedure, I am putting a table and I am finding out what is my x and y values. From the equation I found out what is y. So y is equal to 4 minus x by 2. I put x as 0, I got y as 2. Similarly, when I put y as 0, I got x as 4. Okay, the points are 0, 2 and 4, 0. 0, 2, 4, 0. So now this is my first line. Okay. Similarly, you form the table for second equation also. Okay, so what is my second equation? So I have taken values for x randomly. From the second equation I have written what is y, 12 minus 2x divided by 4. Then I substituted x as 0, I got 3 for y. Substitute y as 0, you will get 6 for x. So what are the points now? 0, 3 and 6, 0. 0, 3 are x is 0 and y is 3. So you will get this point. This is 0, 3 and here it is 6, 0. Joining these 2 points you will get this line now. So, okay, so what you can observe from these two lines seems to be parallel to each other. Therefore the given lines are parallel to each other. This is what the conclusion you can make from this graph. Okay.